So, you want to meet the team that helps me get throughout the day? Let me introduce you to my emotions. Here's sadness, anger, fear, disgust, and of course, joy. They're always there, working together to make sure everything runs smoothly. Or, sometimes it's a little chaotic.
Are you sure we want to do this?
In we go!
Okay, going in, yes!
Wow! I'm surprised! The math lesson today was easy and interesting. Combinations are a piece of cake once you get the hang of them. It's all about choosing things without caring about the order.
Combination is selection from a group of items without regard to their order. It is denoted as the combinations of n objects taken r at a time, or simply n choose r, and is given using the presented formula, where C refers to the number of combinations, N refers to the total number of objects in the set, and R refers to the number of objects selected from the set.
Wait, what? I'm confused. We just talked about permutations in the last lesson, and now we have combinations? It's all mixed up. How do you differentiate both of them?
Chill out, Fear. Let's figure this out together, okay? So, permutations are all about order. Like arranging things in a specific way. For example, if Riley wants to pick 3 different flavors of ice cream and she's deciding the order she wants to eat them, then that's a permutation.
That's right. On the other hand, combinations don't care about the order. For example, Riley chooses 3 flavors of ice cream from a menu. If she picks 3 flavors, vanilla, chocolate, and strawberry, it doesn't matter if she eats them in any order. It's still the same set of flavors. So, that's a combination.
Wait a minute, that actually makes sense. So it's about whether we care about the order of things, right?
You got it. Combinations are all about the selection of things, not the order. Permutations, on the other hand, are about the order.
Okay. Oh, what do I need to do? Math is our first subject. Oh, right. Hope my math homework class. Let's see. Oh, math is our first subject. Problem 1. Hope I'll do well in class. Is forming a 5-member project team from a group math is our first subject, which consists of 7 engineers and 5 managers. Oh, the team must include at least 2 engineers and at least 1 manager. How many different ways can the team be formed? Math is our first subject.
Problem number 1. A company is forming a 5-member project team from a group of 12 employees, which consists of 7 engineers and 5 managers. The team must include at least 2 engineers and at least 1 manager. How many different ways can the team be formed?
Let me solve this one. We're just gonna use the formula. This problem would involve 3 cases. Let's start. Case 1. 2 engineers and 3 managers. 7 choose 2 multiplied to 5 choose 3 is equal to 7 factorial divided by 2 factorial times 5 minus 2 factorial multiplied to 5 factorial divided by 3 factorial times 5 minus 3 factorial. Expand and cancel. The result would be equal to 210. Case 2. 3 engineers and 2 managers. 7 choose 3 multiplied to 5 choose 2 is equal to 7 factorial divided by 3 factorial times 7 minus 3 factorial multiplied to 5 factorial divided by 2 factorial times 5 minus 2 factorial. Expand and cancel. The result would be equal to 350. Case 3. 4 engineers and 1 manager. 7 choose 4 multiplied to 5 choose 1 is equal to 7 factorial divided by 4 factorial times 7 minus 4 factorial multiplied to 5 factorial divided by 1 factorial times 5 minus 1 factorial. Expand and cancel. The result would be 175. To find the total number of ways to form the team and all the results of the three cases, 210 plus 350 plus 175 equals 735. Therefore, there are 735 different ways the team can be formed.
In a game of Monopoly, a player is strategizing which properties to buy to maximize their chances of winning. There are 12 available properties on the board, but the player can only afford to buy 5 of them. Additionally, there are 4 railroads, and the player wants to purchase exactly 2 railroads along with their properties. Number 1 question: how many different ways can the player choose 5 properties from the 12 available properties? Number 2: how many different ways can the player choose exactly 2 railroads from the 4 available? Number 3: if the player first selects the railroads and then selects the remaining properties from the non-railroad properties, how many total ways can they make their selections?
We will also be utilizing the combination formula. This problem involves multiple cases, so let's start. First, we need to find the number of ways to choose 5 properties from 12 available properties using the combination formula. Now we will substitute the values n equals 12 and r equals 5. Then we will get this. Now we will expand and cancel the factorials, and that will give us an answer of 792 ways to choose any 5 properties from the 12 available. And now for the second case, let's consider a more specific scenario. The player wants to buy exactly 2 railroads, and the remaining 3 properties must come from the 8 non-railroad properties. First, we find the number of ways to choose 2 railroads from the 4 available using the combination formula. And now we'll expand and cancel after we substituted it, and that will give us 6 ways to choose 2 railroads. Next, we find the number of ways to choose 3 non-railroad properties from the 8 remaining properties using the combination formula again. Now we will substitute them, then we will expand and cancel. Since the player must first choose the 2 railroads, then choose 3 non-railroad properties, we multiply the 2 results. So now we'll multiply 6 times 56, and that will be equal to 336. So therefore, there are 336 ways to select exactly 2 railroads and 3 non-railroad properties.
Barles bought 3 lottery tickets hoping to win big money. The lottery ticket involves selecting 6 numbers from a pool of 35. What are the total possible combinations Barles can draw in the lottery?
Okay, because our total number from the pool is 35 and we only need 6, our equation would look like this. 35 factorial over 6 factorial multiplied to 35 minus 6 factorial. First, we'll subtract the 1 inside the parentheses, so it will become 29 factorial. Then, we expand the factorial. We cancel out 29 because 29 factorial and the factorial from above 29 on the numerator, they cancel each other out. In order to make our equation easier, we cancel these numbers, so we'll be left with smaller numbers instead. Now, we're left with just 4 on the denominator. Multiply the numerator, then divide to 4. Then finally, our answer would be 1,623,160 possible combinations.
Yes, she did it. Homework complete.